Okay, in this lesson, we have sort of set the stage for what life was like before food production, different types of food production. And then now we are going to investigate and kind of some clues from the past. One of the big topics within archaeology in different areas is when did food, plant and animal domestication arrive in different areas? So archaeologists are looking for clues to plant and animal domestication and clues to different lifestyles, clues to civilization, and evidence of what kind of food sources people were using, so on and so forth. So this kind of brings us into the field of bioarchaeology, which is focusing on examining human remains to determine past lifestyles. So we're getting a little bit of a peek into this field with this lesson. So bioarchaeology is just one of the many subfields of archaeology. Bioarchaeology is a field of study that focuses on the examination of human remains to determine past lifestyles. For example, were people foraging or practicing some sort of food production? It shares goals with both archaeology and biological anthropology, or paleoanthropology. Like archaeology, bioarchaeology is an examination of remains to determine past cultures, but it doesn't focus on cultural remains, such as tools, it focuses on biological remains. Bioarchaeologists may form a picture of ancient life at a particular site by examining human remains to reconstruct their physical traits, health status, and diet. Even evidence for social status can endure in hard materials such as burial goods, buildings, and even bones through the ages. Differences in stature or height, for example, may result from differences in diet due to lower or higher social status. Bioarchaeologists can even study the chemical compositions of bones to determine types of diets. A more varied diet, as evidenced by many different isotopes, may indicate higher status. One primary topic of interest in bioarchaeology is the types of subsistence method or adaptive strategy used by people of the past. For example, when did maize agriculture arrive in the American Southwest? So that is the farming of corn. When can we find evidence of agriculture, or can we find evidence of agriculture in human biological remains? This brings us to this module's topic of subsistence strategies and the first farmers. In the next few slides, we'll examine a little on the effects of food production as evidenced by human remains, mostly bones. So, we're looking at an adaptive trade-off here. We're going to be seeing some health consequences when food production, especially agriculture, is brought into the mix. So, domestication was a good thing for many reasons. The population exploded because there was more food to sustain these populations. So, food domestication allowed humans to grow enough food to sustain a massive population growth at the beginning of the Holocene. This population boom continues today. 2/3 of all calories and protein intake now comes from cereal grains like wheat, barley, corn, and rice that were domesticated in the early Holocene. So during this Neolithic transition I was telling you about. Rice alone accounts for 50% of the caloric intake of nearly 2 billion humans. And we're going to see a population growth slide on the next slide here. So here we can see this stark increase after the agricultural revolution or transition and this explosion in population growth. Even more so, there's another huge spike when modern medicine was invented. Things like antibiotics and vaccination that helped us combat infectious diseases. Helped our populations grow even further. Domestication has led to the establishment of permanent human settlements, villages, cities, and whole societies. Many of the great civilizations of the past in China, Egypt, South America, and Mexico were fueled by agriculture. And agriculture has driven many technological innovations that allow us to grow, store, and transport more and more food to a growing population. It is therefore tempting to think that agriculture has been nothing but a positive innovation. However, there are always trade-offs, and domestication is no exception. Of course, the effect of domestication on human populations has been positive overall. By domesticating plants and animals and controlling their growth and production, more humans could be fed, leading to an increase in our population. In some places, this led to a food surplus, which can be used to feed those who are in need. Long-term food storage allows us to feed ourselves during the unstable years when excess rain or drought reduces the crop yield. However, this change has also come with some negative consequences, as well as continued evolution or changes to our biology. There's a common misconception that human evolution ground to a halt with the modern Homo sapiens sapiens. This is entirely false. Human evolution has continued, and our biology has changed since the late Pleistocene. Much of that biological change has been affected by the advent of agriculture and other changes related to our diet. So first, we're going to look at a little cheat sheet here. Soft food and biological change. So this even changes the shapes of our jaws, our skulls, and the alignment of our teeth even. So the shift to agriculture and the eating of softer foods resulted in biological changes to the face, jaws, and teeth of modern people. Although not universal, some tendencies characterized in the skulls and teeth of hunter-gatherers, the different types of food production, so hunting and gathering versus agriculturalists. And we can see some of those here. Some notable differences, especially, are misalignment of the teeth and tooth wear, differences between those two things, sizes of the skull and jaws as well. Other things we can see are differences in the bone strength. The type of strength needed to hunt and gather is entirely different from what people may have living in agriculturalist societies, all right? It is a much more harder and laborious life for many hunter-gatherers. They build this muscle strength, which translates into bone strength, and agriculturalists don't have that same bone and body build, and we can see this by looking at the cross sections of the bones here. So this reflects reduced activity patterns, and this also has led to a reduction in some populations of degenerative joint diseases like osteoarthritis. Excess stress on joints from carrying, lifting, and any physically demanding activity can break down the protective joint cartilage over time and lead to excess bony growth. Osteophytic lipping or spurs can form in the bone from arthritis of the lower back. These pathologies are often found in skeletons of individuals who are quite active. So for some individuals, the shift to farming dramatically increased workload, and osteoarthritis is rampant in those individuals. So we're seeing changes in some groups within these agricultural societies. The people who are going to be doing more labor would have these evidence in the bones. The people who are doing less labor would show evidence in the bones for less labor as well. So if we're seeing societies that look stratified, or societies where some people are obviously doing a lot more of the work than others, it's much more likely or indicative of an agricultural society. So here in this slide, we're seeing kind of some clues of this bone wear and tear, or even fusion here. Shown here is the osteophytic lipping or spurs that can form arthritis from arthritis of the lower back. These pathologies are often found in skeletons of individuals who are quite active. Okay, so there are evidences in the bones of lifestyle, including the differences between hunting and gathering people and agricultural people. And then even within agricultural societies, we can see evidence of hard labor, perhaps the activity of people who are having to do most of the farming. That would be evidence in the bones as well. And evidence in the bones of little physical activity would show as well. Now we're going to move on to a different negative factor, or a different negative consequence of agriculture. This is population crowding and infectious disease. Agriculture, disease, and population increase are intimately connected. Linked to these changes in human life in the Neolithic is a shift from a migratory lifestyle to a sedentary one. These changes have led to humans living in densely populated and unsanitary conditions. This overcrowding is a recipe for the spread of infectious diseases, and human evolution has been strongly shaped in the last 10,000 years by our exposure to these diseases. One way we know that past agriculturalists were exposed to many infectious diseases is, again, to study the bones. Infections, such as those caused by the Staphylococcal bacterium, can impact bone growth, causing a swollen region called a periosteal reaction. Though the bones indicate that there was an infection, it's impossible or difficult to determine precisely what caused it. Nevertheless, periosteal reactions are extremely rare in pre-agriculturalists and more common in Neolithic and more recent skeletal remains. There are other types of damage on the bone where we can tell what the precise cause was. Lesions on the skull are often accompanied by leg bones that are enlarged and bowed. This is caused by a group of diseases called treponematosis, which can include syphilis and yaws. Other diseases found in skeletal remains of Neolithic humans include tuberculosis, measles, mumps, cholera, the flu, and smallpox. So in the Old World, these diseases were rampant among agricultural societies. There were crowd diseases in the New World as well. There is skeletal evidence that diseases such as syphilis and tuberculosis were in fact present in overcrowded regions of the New World prior to European contact. This brings us to one of this week's optional readings, or I think I might have assigned it this year, The Arrow of Disease. It's going to show us a little bit about zoonotic diseases, so diseases of animal origins, and how their spread historically has affected politics, warfare, and colonization. So again, the Arrow of Disease discusses and describes the origins of many crowd diseases that humans are now often vaccinated for in childhood. You'll recognize many of the diseases discussed, and the whole topic, which I cover every semester, is of course relevant to the COVID pandemic, as zoonosis is one of the hypotheses for how COVID-19 evolved and emerged. So let's look at the stages of zoonotic diseases. So to clarify, a zoonotic disease is a disease that is passed from animals to people. And as you can imagine, when humans started domesticating their animals, they were living in close contact with them, and their filth, we haven't even talked about that, but diseases has been spreading from animals to humans ever since animal domestication began. And it became even more common when people developed these larger populations, when populations grew, and it became sort of a feedback loop between humans and animals, and this has continued for, over 10,000 years. Okay, the 5 stages of zoonotic diseases. Stage 1, the pathogen is present in animals, but it does not infect humans under natural conditions. For example, feline distemper. Stage 2, the pathogen can be transmitted from animals to humans, but it cannot spread from human to human. Example, the Nipah virus. Stage 3, the pathogen can be transmitted from animals to humans and can pass between humans. However, the pathogen is not well adapted to humans, and the pathogen will die out after a few cycles of transmission. Example, the Ebola virus. As we know, there outbreaks of Ebola do happen, but in this case, Ebola is so virulent that it either kills people before it can spread too far, or it's just kind of dies out and is extinguished. Stage 4. The pathogen can be transmitted from animals to humans and can pass between humans. It can adapt to living in humans for long periods of time without going back to animal hosts. For example, cholera. And finally, Stage 5. A pathogen that exclusively infects humans. The pathogen may have co-evolved with humans or colonized humans recently and evolved to a specialized human pathogen. Example, HIV. So these are kind of how zoonotic diseases emerge or mutate or evolve. Keep in mind, earlier semester we learned about mutations, and hopefully you can imagine how something like a virus or bacteria can mutate and become more compatible with its host, and how these stages of zoonotic diseases can occur. And I'm going to show you one more slide, which gives us some evidence or examples of diseases shared with animals of zoonotic origin that infect humans. Okay, here we go. So, humans are in the green circle here, and from wildlife, we have been able to contract diseases like Lyme disease, monkeypox, hantavirus, Ebola, and SARS. From livestock, we've been able to get bovine, spongiform encephalopathy, E. coli, cowpox, and Rift Valley fever. Some diseases can infect humans, wildlife, and livestock, including rabies, the West Nile virus, tuberculosis, anthrax, tularemia, plague, salmonella, avian influenza or bird flu, and brucellosis. Okay, so this is not a very fun slide, but it is an example of how evolution and mutations work, and what can happen when we are mixing humans and animals. We don't have the if we don't have the medical protections necessary or the sanitary protections necessary, these diseases can emerge. So this concludes this part of the lesson. I hope this has gotten you to think about agriculture and health, and even zoonotic diseases. Thank you for listening to this lesson, and please proceed to the rest of your module.